Alright, so section 6.6 is on something called rational exponents. That means exponents are like fractions. And basically the pattern here is this. First of all, this right here, the negative exponent always means flip it and make it positive. So we're going to flip this to the bottom of a fraction and make that exponent positive. This number here tells you what root you're taking, and this number here tells you what power you're raising it to. So the way that I remember this is the roots of a tree are on the bottom of the tree, and the roots of a number are on the bottom of that fraction. So how can we say this? We could say 1 over the cube root, because we're taking a root of 3, the cube root of 6n, and that whole thing to the 4th power. You could also write that as 1 over the cube root of 6n to the 4th. It doesn't matter which of those you use. So let's double check that we did that correctly. And there it is. They happen to write it like the second version that we wrote. Okay, now let's go the opposite way. This is now taking a radical, writing it as a fraction exponent. So in this case, we're doing 1 over 3n to what power? Well, we're taking the 4th root, so the root goes on the bottom. We're raising it to the 3rd power, so the 3 goes on top. And then how can we make it so we don't have stuff on the bottom? Well, if it was flipped to the bottom, that must mean it started out as a negative 3 over 4. So 3n to the negative 3 over 4, and that is the answer. So let's apply this with numbers now. So 64 to the negative 3 halves, that's like 1 over 64 to the positive 3 halves. That means take the square root and then raise it to the 3rd power. Let's take the square root of 64, then raise it to the 3rd. Square root of 64 is 8, and 8 to the 3rd power is 512. So that's the same thing as 1 over 512, and there's the answer. Okay, right here, this is saying take the cube root of 216, because the root is on the bottom, and then raise that to the 4th power. The cube root of 216, what number times itself 3 times is 216? That's 6. And then 6 to the 4th power, 6 times 6 times 6 times 6 is 1296, 1296, and there's the answer. Alright, down here we have 81n to the 4th to the 3 halves, so let's just treat each of these individually. That to the 3 halves, and that to the 3 halves. So this means take the square root of 81, then raise it to the 3rd power. Square root of 81 is 9, and 9 to the 3rd power is 729. Here all we need to do is just multiply those fractions. So 4 times 3 over 2 is 12 over 2, which is the same as 6. So that's the same as 729 times n to the 6th, which is right there. Alright, next one here. So first because of that negative exponent, let's flip it and make it positive. So 1 over 32 a to the 15th to the positive 2/5, and now it's the same as the other one. So let's do 32 to the 2/5. That means take the 5th root of 32 and then raise it to the 2nd power. 5th root of 32, what number times itself 5 times is 32? That would be 2. And then 2 squared is 4. So this is going to be 1 over 4. And then if we multiply those, 15 times 2 is 30. 30 divided by 5 is 6. So that's a to the 6th. 1 over 4 times a to the 6th. Alright, this one right here is actually similar to what we're doing in section 6.4. Very similar, if not identical. So here are the perfect cubes right here. We want to see which of these come out of 81. So let's do the cube root of 81 times the cube root of x squared times the cube root of y to the 5th. The cube root of 81, you might notice that 27 goes into 81. It happens to be 81. It happens to be 27 times 3. I can't simplify x squared, but I could pull out what power would work with a cube root. I could pull out from y a y to the 3rd. So we could write it like this. So now let's go down the line. This equals 3. This right here equals y. And then the rest of it can't come out of the root. So I took care of this. I took care of this. I need to combine 3 and x squared and y squared underneath the cube root, since none of those can be simplified any further. None of them can be taken outside. So there's the answer. Okay, this one is 4th roots. So let's write down the powers, the numbers raised to the 4th power. So these are going to be like this. And we don't have to go past that because it's 243. So let's do 4th root of 243 times 4th root of u to the 5th times fourth root of v, and obviously you're not going to be able to do anything with the v. Which of those fourth powers comes out of 243? It happens to be 81. It's 81 times 3. U to the fifth we could break into u to the fourth, because that would allow me to take the fourth root, and then u to the first, and then we still have that that power v right there. So this equals, the fourth root of 81 is 3. This right here, the fourth root of u to the fourth, is u. And then remember, we're going from an even numbered power to an odd numbered power, so we need absolute values around that. And then the rest of it can't be simplified any further. So this thing, 3, and the u and the v, are going to stay underneath that root, and that would be our final answer right there. Actually, they didn't have the absolute value, but it's not really all that important. Okay, the next video, what we will do is we will pick up with simplifying these right here. And again, that's very similar to what we already did in section 6.4.